All right, so we're going to finish 4.6. Um, we stopped here with example 5, where you guys went through and wrote your equation. We talked about how when we are creating the equation, we're using our vertical asymptote, our horizontal or slant, our x-intercepts, and our poles to create the function, the equation of the function, okay? So now we're going to talk about analyzing it even further. So if it says, given the interval where f of x is increasing, well, if I'm looking for where f of x is increasing, I'm looking as I read the graph from left to right, at what point is my graph going up? And the answer is, in this case, never. Does not apply here, right? And then it says, when is your graph decreasing? Well, it's decreasing from negative infinity all the way to -2, then -2 till infinity. If you want to be precise, you could write -2 to 1, then 1 to infinity, but I'm not going to be that picky. So we decrease from negative infinity to -2, and we also decrease from -2 to infinity. Okay? When it says f of x is greater than 0, this inequality is asking you, when is your function above the x-axis? Okay? And it only is from -2 to 4, because this is where our x-intercept is. Okay? And then it asked, so from -2, oh, that's not, 2 got weird, to 4. And then it asks, when is it below the x-axis? Because that's what is less than 0. And below x-axis. And I'm below the x-axis. Let's look. From negative infinity to -2, and from 4 to infinity. I am below the x-axis in those windows. Agreed? So we had negative infinity to -2 and 4 to positive infinity. Next is asked to evaluate. What is f of 1? So this is saying when x equals 1, what do I get? So if we look at our graph, when we go to x equals 1, what do we have? What's this? A hole. So does it equal anything? No, it is undefined there. And why is it undefined? Because there is a hole in my graph. Okay. Next it says, what is f of 2? So when x equals 2, what do we get? I'm going to go to 2, and I'm going to approximate. Oh, it's not a good idea to approximate. So therefore, instead of approximating, guess what we're going to do? We're going to plug it in and actually find f of 2. So we're going to plug in to find f of 2. So we're looking for f of 2. That means everywhere that there's an x, I'm going to plug in a 2. So we have 2 minus 1 times 2 minus 4 all over 2 minus 1 times 2 plus 2. Well, the 2 minus 1s are going to do what? Cancel out. And I'm left with positive 2 over 4, which equals 1/2. So the answer for when f of 2, we get 1/2. So we get y equals 1/2. And last, it says, where does f of x equal 4? So when I'm looking for f of 4, that means I'm going to go to when y is 4. Oh, no, I will 1 second. Okay. And what It approximately looks like what? It looks like it would be 1. How'd you get 0? Yeah. When y equals 4, what would x be? Yeah. Looks like it would be 1. So we can say approximately 1, but we also can actually solve for it. Okay, if you were to solve for it, that means you would be taking 4 and setting it equal to negative x. Forgot it real quick what it said. Minus 1. Minus 1. Spam. X plus 2. Is that what it was? Minus 4. Spam call distracted me. Minus 4 over x minus 1. And then it was x plus 2. These are going to cancel out. And so if I wanted to be exact, I'm left with 4 equals. That negative is going to make it a negative x plus 4 over x plus 2. What would I need to do to solve this? Good job. Multiply by x plus 2. You have to get what's in the denominator out of the denominator. I did not give myself enough room, so excuse the squeezing of the space here. So I'm going to start here. So I'm left with 4x plus 8 equals negative x plus 4. What did you do? If you said add my x and subtract my 8, you are so right. Good job. So we have 5x equals, and 4 minus 8 is?
4.
Negative 4. Oh, and it's not actually 1. It is actually negative 0.8. So we approximated to be 1, but it's actually at x equals negative 0.8. So you see the difference in our approximating and our solving? Oh, my negative didn't make it. Thanks, Daniel. You couldn't just say, hey, miss. Okay.
Wait, so the first?
Yes, that was us approximating just from looking at the graph. And then we went ahead and did the math and actually figured out where it was located. Okay. All right. So that's why I wanted to do 6 with you. 7 and 8 are just more practice of setting up the domain range using your vertical asymptote, horizontal asymptotes to go through it. I will do them if y'all need the additional practice. Yes, we need the additional. Okay. So the domain, reading from left to right, is all real numbers except x cannot be who? Negative 2 and 2. So x does not equal negative 2 or 2. Range, it is all real numbers because I actually end up sliding through here, right? So my range is all real numbers. I have a vertical asymptote at x equals negative 2 and at x equals 2. A horizontal asymptote at y equals 3. And since I have a horizontal, can I have a slant? No. I have 2 x-intercepts, and my x-intercepts are at negative 1, 0, and 4, 0. My y-intercept is at 0, 3, and I do not have a hole. Okay, so we talked about when you're writing your rational function, you want to start with your a, and your a is your horizontal or slant asymptote. So we want to start here. So in this case, what is my a? 3. After we have our a, we want to then use our holes. Do we have a hole? Nope. After we check our holes, we want to use our x-intercepts. Do we have x-intercepts? Yes. So we got to ask ourselves, what factors would make x equal negative 1 and x equals 4? X plus 1 and x minus 4. And then our last stop along this is checking our vertical asymptote. So we ask ourselves, what factors would make our vertical asymptotes x equal -2 and x equals 2? And there is our factored form. Was it terrible? Okay, so we identify and then we follow 4 steps. Use your horizontal asymptote or your slant asymptote. Check for your holes. Use your x-intercept. Check for your vertical asymptotes. Y-intercept, no. It's a dependent. It depends on everything else. Y-intercept. All right, last one. The domain here. Not -1 anywhere else. -2. So x cannot equal -1 and x cannot equal -2. There is a vertical asymptote. You see how the graph curves? It's like, curving you. No. Yeah. Our vertical asymptote is at x equals -1. Do we have a horizontal? No, we have a what? A slant. And where's our slant? Y equals. Remember, to find the slant, you need your y-intercept and your slope. What is the slope of this line?
1.
There you go. 1 and what else? X minus 2. Slant asymptote is at y equals x minus 2. The slope is 1 though, yes. But the slant itself. Your x-intercept, how many do you have? 2. We have the origin, and we have 1, 0. Y-intercept has to be the origin. And we have a hole. Where's our hole? -2, 6. -6. All right, so we're gonna go through the steps again. So the first thing is you look at your your HA and your SA. Okay, if it's your SA, you're only using the slope. And what is our slope? 1. If you don't want to write 1, you don't have to. I'm gonna write it just for the sake of writing. Next, you're gonna look at your holes. My hole is at x equals -2. What factor will give me x equals -2? X plus 2. Because it's a hole, it's in the numerator and in the denominator. Okay? Next, after we look at our hole, we're going to look at our x-intercepts. Our x-intercepts go in our numerator. So we have x equals 0 and x equals 1. What factors would give us x equals 0 and x equals 1? X minus 1 and x. Perfect. Last but not least is our vertical asymptote. What factor will give us a vertical asymptote at x equals -1? X plus 1. Because our hole is at x equals -2. So you're looking what factor would make x equal to -2. Yes. Okay. There's your factored form of your rational. If it asks for your polynomial form, what would you need to do? FOIL and combine like terms, right? All right. That's it for unit 4. We're done, son.